All right, good morning, everyone. How's everyone doing? Good, good. Well, welcome to this session today. My name is Chi. I'm your moderator today, and this session, this is our first talk of the day, and the whole session is related to things like air permitting, testing, dispersion modeling stuff. And so our first speaker today is Mr. Scott Manchester. He's going to give us a virtual talk. He's currently sitting in his office or at home in New York. So Mr. Manchester, he's a director in Ambient services at Alliance. He has 35 years of experience in air quality monitoring programs and includes developing and overseeing parameter air monitoring programs. He's got nearly 30 years of experience in project management, including over 20 years in staff and resource management. His focus experience includes a focus on ambient air monitoring of air toxics, meteorological monitoring, acoustical consulting, and odor assessment. Scott's experience includes developing community air monitoring and quality assurance project plans, and monitoring for a variety of air toxics, including a wide range of speciated VOCs, sulfides, amines, aldehydes, metals, PAHs, PCBs, and odors, including the use of real-time analyzers for fence line monitoring applications. He got a Bachelor of Science degree in meteorology from Cornell University. Okay, Scott, I'm turning the ground to you.
Thanks. I appreciate the opportunity just to spend a few minutes on the topic of ambient air monitoring. We'll just some of the objectives I wanted to run through and talk about are just to introduce and to talk about ambient air quality trends over the past in the past century and recently. And then what are some of the needs and triggers for ambient monitoring today? And then move on. There are lots of aspects of ambient monitoring, a very broad field, but I'm just going to talk about 4 different aspects, maybe a couple of those you're very familiar with and think of when you think of ambient monitoring, but maybe a couple that don't immediately come to mind. And then I want to just wrap up with just a couple points in how I think ambient air monitoring programs can a couple of things that can be helpful in creating effective public communication. So just to start to talk a little bit about ambient air, it's actually specifically defined by the EPA as that portion of the atmosphere external to buildings to which the general public has access. And that really is there to exclude anything indoors or even on site at facilities and projects. So just the areas outside in the public. Ambient air doesn't mean that it's free of all pollution. You'll see that in some definitions, some areas, but air pollution episodes occur naturally and always have, especially when periods of stagnant weather occur. But last century, increases in population, coal use, industrial processes, there have been more and more severe episodes of events. And here's just a few from New York City. Smog events happened in 53 and 63 and again in 66. Very serious smog events where they attribute at least 200 deaths during every event immediately to just that event. And I'm sure there are lingering other health concerns after that, but you can see a picture and I think we can all agree none of us really want to be there at that time back in the 60s. But there's good news since the Clean Air Act and the US EPA was brought up in 1970. Since that time, there's been increase in some regulations related to air quality to help control and reduce these pollution events, and specifically for measuring ambient air quality and the development of the later development of the Code of Federal Regulations. Three parts of Title 40 that specifically address ambient air quality, and that's Part 50 that talks about standards for air quality, and 53 that talks about the reference and equivalent methods for doing the monitoring, specific equipment types that have been evaluated, and then a Part 58 that talks about surveillance, which all these really so that the monitoring data can be relied upon and is accurate. And the good news is that emissions, as a result of regulations, have dropped 78% since the establishment of the Clean Air Act and the EPA in 1970, and which is had an effect, obviously, on ambient air quality. And over the last 30 years, you can see the trend line as the EPA tracks trends in ambient air quality. That has improved by 25 to 90%, but depending on the compound they're looking at. So you can see levels have dropped over that consistently over that period of time, which is a very good story. But it has led to an increased public awareness and engagement. And that's something that really drives some of the monitoring objectives we have today. So just some of the objectives are, of course, documenting and tracking air quality, and then also evaluating any changes or source impacts that they may have to ambient air. But generally, the big one is we really want to demonstrate the protectiveness, and that's the goal, is to protect public health and welfare and keep us all safe and sound. So you may ask, when and why do we do ambient monitoring? Well, always can be pre-construction, during construction, operations and expansions. It triggers ambient air monitoring, and even after shutdown, ambient air monitoring is really important. In pre-construction, we use it to understand the existing conditions and baseline levels. We also use meteorological data, which is part of ambient monitoring, as data input, so we can have accurate, it's on-site data, so we can have accurate pollution dispersion air modeling. During construction operations, there are of course regulatory and permit compliance to meet that triggers ambient monitoring, as well as protecting the public health and welfare, and sometimes just in response to community concerns and complaints, to help assure them that levels are not going to be unhealthy for them. But after shutdown, things don't. The start of a facility shuts down, there's demolitions. Those can emit various pollutants and air toxics, as do site remediations and cleanup of contaminated soil. And so there's ambient monitoring needed for those under those situations to protect health and safety from primarily from short-term exposure to air contaminants, but also there can, if these are multi-year programs that are going on and on, there can also be air monitoring in comparison to chronic exposure criteria. So just to talk about some federal standards and triggers for air monitoring. The big one that most folks are aware of is National Ambient Air Quality Standards, and those talk about 6 criteria: air pollutants, 4 or more gases: CO, NO2, SO2, and ozone, and particulate matter. That's inhalable particulate matter less than 10 microns in diameter, or fine particulate less than 2.5 microns in diameter. They count those as one, I guess. And then lead, also airborne lead, there is tracking as well. The other trigger is EPA has a list of hazardous air pollutants. They're also called air toxics, and those are compounds that have cancer and potential serious health risks to them. So those also can trigger air monitoring. But there are some other challenges that air monitoring programs help address, and that is identifying and differentiating on-site sources from off-site sources. Not everything's caused by the facility. Sometimes it's off-site, and so we need to know when that is and the sources. Also, everything's non-air toxic, but we protect the public from we want to protect the public health, but also welfare, or really their quality of life. So and I'll talk a little bit about that as well today. And then air monitoring really can be a conduit for just for public air quality awareness, as well as communicating with our neighbors. Wanted to just run through. There are many aspects of ambient monitoring, but I've just selected a couple really common, and that's fence line monitoring. You're talking about monitoring for criteria air pollutants or other air toxics. The fence line monitoring, depending on where you are, here in New York State, they refer to it all as community air monitoring. If I'm over in New Jersey, they're going to refer to it as perimeter air monitoring, but it's all the same thing. It's all fence line monitoring at or near the fence line. Another important aspect of monitoring is meteorological monitoring. A lot of times those are associated with fence line monitoring programs, but can be set up just by themselves, even if there's no fence line monitoring going around. Again, with something that can be separated. And then the other two areas and aspects are monitoring are really related to public welfare, and that's noise and odors. So we're going to talk a little bit about those. As far as fence line monitoring goes, generally for all fence line monitoring, we're looking at the NAAQS criteria, pollutants or targeted air toxics, depending on the program, at or near the site fence line. And then the purpose of that is really to get it before it reaches out into the public. But that does mean that sometimes, on occasion, there's that the ambient monitoring's also done offsite in the community as well. And the pictures here, if you take a look at those 4 dots, are ambient air monitoring stations. So this is for a remediation, and this is some contaminated sediment that they want to keep track of air emissions off of. And the monitor on the right is a particulate monitor, and at each of the 4 stations, plus there's an open path UV DOS monitor that's I think that's monitoring along the yellow fence line, if you will, all the way around. They're set up at each corner, and I think in this situation, I think they were measuring one of the things they're measuring was naphthalene. So if the program's going on measuring against the criteria air pollutants, it's typically following guidelines that discuss ambient air monitoring in 40 CFR 50, 53, and 58. It's going to specify real-time gas analyzers, reference method models, or perhaps equivalent methods, but those are going to require temperature-controlled shelters. So there's that they're important to keep the temperature at the right level so that these can maintain their accuracy. These systems also typically can use real-time and or 24-hour integrated particulate samplers for monitoring dust and airborne particulate. And then also generally at one of the locations is going to be located at the 10-meter meteorological tower. 10 meters is the standard height. It's going to be in a very open area because there's a strict siting criteria to make sure that you're getting the right flow and not being having nearby obstructions affect that air wind direction and speed. These programs are going to also require and adhere to a quality assurance project plan. That's a fairly involved document. It's going to talk about the monitoring objectives, the sighting, instrumentation, some accuracy. It's going to discuss QA/QC activities, including standard operating procedures for the operations and data management and reporting. Often these programs are going to require third-party audits, so the EPA may actually come out and do the third-party audit on the system to evaluate accuracy. And in the QA plan, data quality objectives are discussed, and also data reporting requirements. And in some of these monitoring programs, data is going to be electronically uploaded to the EPA AQS database, which is a national database. So other contaminants also trigger fence line monitoring. Anytime there's a potential for migration of fugitives or air toxic offsite, demolitions and remediations fit that bill. Think federal Superfund sites for sure, and brownfields. But facility processes, the compounds can also trigger some monitoring, and it may be a chemical facility or a refinery with a specific compound that needs to be as required that they monitor. These are very program specific. So in some instances, they're very simple. They can be as simple as for a brownfield, an upwind and a downwind monitor that get moved as the wind changes. Or they can be very complex. They can be measuring using an FTI or FTIR or a field GCs to measure specific compounds at very low levels. So it really depends on the program. But typically, you're going to look at real-time monitoring and as well as potentially periodic sampling as part of the programs. Continuous monitoring, often VOCs and PM10. Can be done for those parameters, or real-time surveys of some specific parameters. We've done H2S sampling and mercury sampling using handheld monitors in a survey fashion around the perimeter. Periodic sampling can be done for a whole host of compounds, and depending again on what the program's specifically needs and the potential contaminants. And again, these may also include offsite sampling in the community, really to confirm levels are within, to especially if the community is is concerned about what's near their home. So sometimes levels are measured in the community. So there's some challenges to that. Certainly security. You'll need a fence typically around, or things chained down, but still their vandalism can occur if people are not particularly excited about the whole thought of monitoring, but also there's the challenges with trying to define the background sources on an area that's not controlled at all. There may be fixed background sources, or even background sources that just that are transient. So there, for instance, a car could be idling right next to the monitor, and you don't necessarily know that until you come back and you have it analyzed and you see it's a high level of something that you don't know where it came from. So background sources tracking is a problem for offsite. The next aspect of ambient monitoring that we get involved in typically is meteorological monitoring, and that can be, as I said, associated with fence line programs, but can be standalone. On site, usually at 24/7 real-time monitoring with sensors measured typically for NACS projects at a 10-meter tower, but for some remediation programs, or in certain instances where they need to move them around, portable stations are set up at maybe a 10-foot on a 10-foot tripod. The winds, often the parameters consist of wind speed and wind direction, temperature, RH, and pressure as well. Those are fairly standard monitoring parameters. And for these programs, there's going to be documents describing siting, QC, and reporting. Sometimes if it's a required network by, for instance, a state may require a monitoring station. Then a QAPP may be developed, but in some cases, a less detailed, just a more simplified monitoring plan can address these items. And data usage, I think we talked, indicated that before and ahead of construction, these are data. This data can be used for dispersion model input, for on-site weather data and wind data, on fence line monitoring support, in interpreting data, whether the source is on site or off site. But on standalone systems, sometimes this is often used just purely for situations where they need to know the winds right away. For emergency responses, they find out where the upwind safe area can be to meet, or downwind directions that might be at risk of a plume or smoke from a fire or something like that. So that's important use of these weather towers as well. Now I wanted to talk about a couple other aspects of ambient air monitoring, and that really relate to protecting public welfare and quality of life. And that's one of those is noise monitoring and an assessment. And noise, the definition of noise here is unwanted sound. So there's sound everywhere. Sometimes it's unwanted though, and so noise assessments typically consist of conducting sound level measurements and then assessing impacts. If you don't have the source isn't in operation and there's going to be a source to be put in operation, then noise modeling is performed. And then mitigation and control is an important part of the noise monitoring programs. In sound measurements, typically those sometimes they're at the fence line, but more often than not, they're out in the community, and that's surveying to determine what the baseline conditions are, and sometimes it's compliance with to use with the baseline to determine compliance. And these are typically done in the community at what are called noise sensitive receptors. And those are areas that are particularly sensitive to impact from noise, such as residences or schools, maybe at playgrounds or places of worship. So that's usually the target because they are bothered by the noise first. Then when impacts are assessed, oftentimes noise is really falls to local ordinances, although there are some state and federal guidelines depending on maybe the type of noise source, but often local ordinances, and they may be very specific. They may say X number of decibels, and those can be compared to directly, but a lot of times they can be very vague in small towns. So where they'll say something like may not create an annoyance or be unreasonably loud, and that's a very hard thing to evaluate, quantify based on decibels, but fortunately, impacts can be pretty readily assessed based on increases to existing background. So we, for instance, know that if sound levels are going up by 2 or 3 decibels, broadband sound levels, then that's going to be probably just fine. People aren't even going to notice that. But if sound levels are going up, 6 or 8 decibels or 10 decibels, that's going to create, that's going to turn heads. That's going to create a problem with the community, and so that's something that is resulting in an impact. The other thing that can result in impact is tonal noise. Tones are widely prohibited over the background. So and we can specifically measure prominent discrete tones and evaluate if those are a problem as well. If you're putting in a new source, then noise modeling can be done on new sources, and that essentially we can take data from sound level data taken at the source or that's being emitted from the source, And if we don't know specifically for that source, we can take the equipment size and type. There's a lot of empirical data out there that can really is fairly accurate in telling how much noise a type equipment type and size will make. And that can be modeled out using software and taking into account attenuation due to distance and terrain and obstructions and even a directionality of the sound. And if you, on the right, lower right is have some model output, some sound level contours. Those are sound level contours, and I believe it's a proposed shooting range where you can see the bullseye, if you will, that in red there. That's where they're coming from, and they're emanating out across the area to the sensitive receptors, but not all equally, because this is where distance and this is where terrain and obstructions reduce sound levels. So you could actually have somebody further away getting much louder sound levels than somebody near closer in who maybe has some terrain or some intervening trees or soft surfaces that reduce the noise traveling to them. So that can give a good idea. And when impacts are shown, then mitigation can be proposed. If it's a new source ahead of time, enclosures can reduce sound. Other ways to mitigate are putting lagging and putting up barriers. We've all seen barriers put along the highway and to reduce sound. They just keep the sound from traveling straight to the receiver and the sensitive receptors, because it has to go up and over, and that can reduce sound levels anywhere from 6 or 8 decibels to as much as 20 decibels. And then, but also operational constraints. So sometimes it's a matter of operating the equipment at different times. Daytime's better than nighttime. Higher background sound levels, and or it could be operating at a different speed. Sometimes certain speeds are problematic and make more noise than other speeds that something's operated at. There's also different types of equipment that there's low noise. A lot of equipments that make a significant amount of noise have low noise either packages or low noise equipment that can be spec'd instead of the regular noise level from the equipment, and they just have they're effective in mitigating a certain noise, like a low noise generator. And then that can be confirmed with measurements afterward, just to verify the proposed and the modeled sound levels are meeting what is actually occurring. The final aspect of ambient monitoring I wanted to raise is I see it as very similar to noise in that it's affecting quality of life, but maybe even more so in today's world. Odors are evaluations are increasingly important, it seems like, and that going through an odor evaluation involves observing the odors, then understanding and measuring their strength, and then how they're impacting others, or maybe looking at specific odor sources and finding out which ones are the heavy hitters of the most odorous of those sources. So it gives a direction to what should be controlled. So in odor observations, those can be at a fence line or of sources. They can be either qualitative or quantitative. The qualitatively just involves an odor observer talking about the strength, and usually descriptively, like that's a perceptible odor, barely perceptible, or a light, moderate, or strong odor. It's quite subjective. Frequency would words of frequency would be something like fleeting odor, or we've used intermittent or persistent odors. And then the character, which is really just a description of what the odor smells like. That could be musty or sulfury, could smell like oily smell. So that's really just to describe what the character of the odor. But those are qualitative. Odors can be evaluated, especially for strength, quantitatively, using olfactometers, and those essentially are devices that the odor goes through, and then clear odor-free air is mixed in and dilutes it, and by how much tells the strength of the odor. There's versions of the real-time olfactometers that can be taken out in the field, and that the one on the upper right is an example of a real-time field olfactometer that can be breathed through, and then the mixing of odorized with clear fresh air changed, and the dilutions changed. Or we can collect whole air samples and bring those back to a lab for a olfactometer that's in the lab, and on the lower right is an example of that, where they have a trained odor panel of individuals that are able to evaluate odor strength by comparing. This is called a triangular forced choice monitor here, where you're smelling three different outlets, and to try to determine if one of them has an odor, because two of them will be blank and one will have an odor, but they keep changing the concentration and mixing it with less and less until finally you can get to the point where you get to the odor threshold. And the strength is measured in what's called dilution to threshold. It's how many times it's how much it needs to be diluted to get to the threshold where you can barely smell it. And the stronger odors, that'll be more. And that's also expressed as what's called odor units, OU. And again, the threshold is where the odor is first detectable, and that's going to vary by person. So the odor panel or field observers, it's really important that they're pre-screened, and you kind of want individuals that are going to have normal or average, if you will, odor sensitivity. You don't want folks that are overly sensitive, hypersensitive to odors, or individuals who can't very insensitive to odors. You want to not use those individuals at all, because they'll skew the results. So once we evaluating the impacts, sometimes the odor strength can just be compared to guidelines in odor units. Some states, some cities, not a ton of them, but have specific odor unit guidelines that'll say something like under 7 odor units would be acceptable. But if you're creating more than 7 OU or more, then you need to correct the situation. That also can be set up for a project, but arbitrarily for a project if there's no guideline. But oftentimes the resort is to qualitative descriptions of what is acceptable odors, and it may say something like anything more than a perceptible fleeting odor is unacceptable, or anything that increases from a non-detectable to and a detectable odor may be unacceptable. So that can vary, and but is qualitative in nature. The other thing that is important is evaluating in odor monitoring and evaluation is about ranking sources, identifying which sources are the most odorous, and that takes into account both the strength of the source, but also the emission rate of what's coming off of the source. So in a lot of cases, lower odor strength sources are the most important to control, because the emission rate is so high. It can be you can have a high odor source, but if the emission rate is very low, then that would not be something you want to address first. And when addressing odors and mitigating and controlling odors, there's a number of things that are done in air monitoring, and that's again, process modifications similar to noise, but in this case, changing the ingredients. We've had clients do that, where they changed something to something that's a little less odorous, and that's dramatically improved their odor. Or changing production rates. That's another process modification that can be reduced odor, or additives to the process. control and capture and control of the odor emissions, much like you would do for reducing VOCs, sending it to a scrubber, a carbon vessel. Carbon does a great job at removing odors. And indoor processes, you can use hoods and small enclosures, and outdoors in the upper right is a fairly large sprung structure that was constructed over top of an area where work is being done, and emissions are being and odors and emissions were being captured and sent through a carbon unit in that picture. Other types of mitigation, physical barriers and covers. Polytarps work great to just prevent odors from escaping, as do in the same premise spray covers. And in the middle right over is not snow, but rather rustmar foam, and that's sprayed over an area, and it's can be temporary. That's really a temporary fix, and but can be sprayed over, and that will suppress the odor emissions from that surface. It's above the surface and in the air. There are odor neutralizer mists and mist curtains that can be set up. Biosolve is one of those, which it can be sprayed and helps neutralize the odors. Pion is often used as a mist curtain, and on the bottom right is a picture where that's a line of misters. That I'm sure the odor source is on maybe one or the other side of that, and as the air passes through that, my understanding to it, the mist absorb the odor molecules into the water droplets, and both neutralize it and help it drop out, and it may drop out into the ground, in which case it is not, it reduces the airborne levels reaching the community. Ambient air monitoring is also, I said I would talk a little bit about communication and how to effectively do that. In air monitoring programs, communication we found has been really critical to the program, and in a couple different ways. If there's an air monitoring program, having a publicly accessible data, and usually that's on a website, is we found is pretty important. Maybe that's a link on the health and safety page. So everyone's understanding that's really the point of doing the air monitoring, and you can either have graphs or tabulated content in there. Some things we found that's important though is to those sites is putting up daily validated data. I mean, we've done it both ways, but validated data is important because it takes out some instances where the public may raise questions about from the public, and it may just be because the monitor was malfunctioning, a spike. So those want to be addressed ahead of time. There should be a comparison to limits on graphs or in the table. In that yellow part of the figure down the lower lower left is some red lines which show the air quality limits for that program. You can tell at a glance, and they can tell at a glance, that this is for particulate monitoring during a demolition, but you can tell that the dust levels were well below average just at a glance. So that helps them to understand and read the graphs quickly, and it's also, we found, noting them, call outs on excursions, if there are any, or inactions. If something is high, call it out and say what it was due to, and what the action was to correct it, or any anomalies in the data. So noting those, there's a dropout in this graph where monitoring was not just trying to be hidden, but it stopped monitoring. There was no data for that period, and we annotated that specifically because in this case, due to rain, there was no monitoring to that period. The other thing we have over there is have on this page is a wind speed and direction tracking, so people can tell when they're upwind and downwind of a monitoring station during the day, and they can match it up. The other important part of effectively communicating the air monitoring program results with the public is addressing complaints. And we found setting up a community hotline can be very effective in giving people a avenue to address their concerns. And but having the right details are important. So understanding from the hotline where the location is, the date and time, and the description doesn't help to say, well, there was an odor last week, sometime, just sometime, and I'm not really sure where it was. But it's important to really be specific, because that way the complaint can be investigated and potentially identify sources, which may be off-site. We have a lot of situations where odors are identified off-site and or not, and you can tell by the wind conditions. It was not a facility operating at all. But that's really important to have the details on that, and to have a process really set in place so that it's dependable, and people can be the results can get back to the complainant. Just here's an example of an odor investigation process flowchart that we drew up, and again, these are going to be specific to each project, each facility, but the overall process here is it brings in it gives it specific flow chart to follow and a process to follow, so that in this case it goes to the agency and the facility managers, and then there's a way to work down with the air monitoring operator to investigate it, then the engineer to make decisions whether controls and countermeasures are required, and then it feeds back through the facility, and then ultimately to community relations, an individual who can reach back out to the complainant and answer their questions on why. And sometimes they don't want to know, but often they would like to know what happened, or why the conditions were like they were. So we found that this is just having this set process is very, very helpful to keeping the public informed, and having good open communication. And that's it. I just like to summarize some of the key benefits in air monitoring, and communicating that are really air monitoring's programs are demonstrating. They're important because they're demonstrating the ambient air quality, that it's within limits, it's safe for the community, but also in with a effect made it up with good communication will help keep the ambient monitoring program status in front of the public, to increase their awareness, and really promote a transparent relationship between the community and the facility or project, and really reduce misinformation, which is the first thing that pops up, and overall that can make things operate more smoothly and reduce risk for any potential work delays or stoppages that can be associated when conditions are not well communicated. And thank you very much. I appreciate your time, and open things up if there are any